There are a number of different accurate drawings that we need to be able to produce. Now, before we can talk about what the drawings are and what practical applications they might have, we need to find the equipment and we need to set ourselves up ready to do the drawing. Most of these drawings we are going to need little more than a ruler, a set of compasses and a pencil. And the first thing we're going to do is we're going to set up the compass and check that we know how to use it correctly. To make sure that we use our compasses accurately, it is important that we set them up correctly. So what I'm going to suggest we do is we find a pencil that will permanently live inside the compass. The compass is made up of a sharp point here and a place to put the pencil. So we're going to put the pencil into the compass. And we're going to place it into the compass so that the point of the compass and the tip of the pencil line up exactly. It is worth taking the time to do this. And if we're taking the time to do it, it is particularly worth taking the time to do this before the exam. So that when we go in, we can just take in our compass and pencil already set up. That does mean that we will need a second pencil to do bits of drawing that are not compass based. So I've made sure that the screw for the pencil is tightened quite tightly. We don't want the pencil to slip while we're using it. The pencil needs to be nice and securely held in the compass. We don't want it to change position or slip out altogether. Next thing, I need to make sure that the arms on my compass are quite tight, really. If they are loose, we're not going to be able to draw things because they will slip while we're trying to draw. So they need to be quite tight. If your compass is not particularly tight, you probably just want to get another one. Next thing, when using a compass, there is exactly one place that compass should be held, and that is here on the handle at the top. The compass should not be held in any of the following places. Compasses are traditionally used for drawing circles and for stabbing people in the arm. Please do the first of these and not the second. Using a compass is actually quite a complicated technical skill, and it's important that we do it correctly. To use a compass, we have to first make sure that we are holding it by the handle. If we want to draw a circle, we need to make sure that the circle we draw is of the correct size. We use a ruler to set the radius of the circle. Say we want to draw a circle with a radius of 4 centimeters. What we need to do is we need to open the compass. We need to open the compass to 4 centimeters, i.e. we place the compass on our ruler so that the point is at the 0 centimeters and we open the compass until the pencil lines up with the 4. That compass is now set to a width of 4 centimeters and that will help us draw a circle with a radius of 4 centimeters. We need to then move the ruler out of the way. We then need to hold the compass by the handle. If we hold the compass by the arms, then the arms could slip and we end up changing the radius of the circle. We hold the compass by the handle and we push the point gently onto the page, not too much or the arm will slip again. But we just need it firmly entrenched on the page. I'm going to hold the handle of the compass and I'm going to drag the pencil around the page. I'm going to tilt the compass, drag the pencil around the page until I get to a point where I can't do any more, and then I might switch direction and go the other way. We need a nice, smooth, sweeping movement of the wrist here. The lighter you press on your page, the less chance there is of the compass slipping. If you push down quite hard, the compass will slip, and you will end up with something that is either not a complete circle or something that changes width part way around. Nice, smooth, sweeping movement. We can go over the circle a couple of times so that it outlines nicely. And then once we move the compass away, we have got a nice circle. The centre of the circle is also going to be marked because it's the little hole in the page where the compass has been pressed in. So we could even mark on the centre of the circle. And if we wanted, we could always draw a radius in and label it as 4 centimetres. So we've drawn a circle with a 4 centimetre radius. Now that we've learned how to draw a circle with a compass, let's have a go at drawing a triangle. Wait, what? A triangle? Yes, a triangle. A triangle has sides AB equals 5 centimetres, AC equals 4 centimetres, BC equals 3 centimetres. Draw an accurate copy of the triangle. The single most important word in that question is the word accurate. And any question that talks about accurate drawing or drawing accurately is a question where you have to reach for more than just your ruler. Because yes, okay, we could easily measure 3 lines with a ruler of 5, 4 and 3 centimetre lines. But trying to construct them into a triangle just using a ruler is going to be much harder than you might think. We'll talk about why along the way. But as soon as you see that word accurate or accurately, you need to reach for your compass, because any of these accurate drawings are drawn using a compass. Here's what we do. We pick one of the sides to start with. It really genuinely doesn't matter which one. I'm going to go for the first one there. It also happens to be the longest. And I'm going to actually use a ruler to draw that first side. So I'm going to use a ruler to draw the 5 centimetre side. I'm going to label that as being 5 centimetres, and I'm going to label the corners A and B as well. A, B is 5 centimetres. Now, the other two sides of the triangle, well, let's draw them above, because that's okay. A to C is 4 centimetres, and B to C is 3 centimetres. So C is somewhere up here, so that it's 4 centimetres away from A and 3 centimetres away from B. Now, I could easily draw in one of those sides. I could easily draw a 4 centimetre line coming out of A. But the chances of getting that line to also be exactly 3 centimetres away from B is quite a tall order, because there are so many different 4 centimetre lines that I could draw coming out of that point A. I could draw one in that direction, or that direction, or that direction. And trying to get one that is exactly 3 centimetres away is actually much harder than you'd think. And that's where the compass comes in. Because what we could do is we could consider all of the points that are exactly 4 centimetres away from A. And to consider all of the points that are exactly 4 centimetres away, we could draw. Well, what could we draw? A is a single point, and we want to consider everything that is exactly 4 centimetres away from it. Surely we could just draw a curve or a circle of a width of 4 centimetres. So I grab my ruler, and I grab my compass, and I set my compass to a width of 4 centimetres. And I'm going to place the point of my compass on the end of that line at A. And on it goes. And I'm going to draw nice and carefully. And I'm going to draw nice and carefully a nice smooth curve around A. I could draw the whole circle in if I wanted, I don't have to. But that curve shows a selection of points that are exactly 4 centimetres away from our point A. Now, one of those is going to be exactly 3 centimetres away from B. So surely I could just get my ruler again and set my compass to 3 centimetres this time. And draw another curve at B. To show exactly 3 centimetres away from B. So I place my compass on at B, draw another curve, and that curve is 3 centimetres away from B. Why is that a useful thing to do? Because look, there is a single point that is exactly 4 centimetres from A and exactly 3 centimetres from B. Where is it? Well, it's where the two curves cross. The two curves cross here. I could simply join that up to A and join that up to B. And I have now gained a point C that is exactly 3 centimetres from B and 4 centimetres from A at the same time. And I have constructed an accurate copy of the triangle. What should I do with those curves at the end of this question? Absolutely nothing. I have to leave them there because I need to show how I have accurately constructed a copy of the triangle. I need to leave my construction lines in. So I'm going to leave the question at that. Draw a locus of 3 centimetres around the point. Now actually, all this is a fancy word that obscures quite an easy thing to do. Locus, one locus, plural loci, that's one locus or 2 loci, is a word that actually would be very sparingly used in the exam. It could be used for a question like this, but it's probably more likely to talk about this in a more practical sense. What a locus is a region enclosing all of the points that are within a given distance away. In this case, we would need to draw a region around this point that shows everything that is less than 3 centimetres away from it in any given direction. And that in any given direction is important, because if we want to mark off an area on this page where every point within that area is less than 3 centimetres away, we need to really find out where the 3 centimetre mark is in every given direction. And that would be nothing more than a circle. So all we need to do for this particular question is draw a 3 centimetre circle around that point, which means we grab our ruler, we set our compass to 3 centimetres, there we go, and we draw a 3 centimetre circle around this point. And that is a 3 centimetre locus around the point. Everything on the line, everything on that circumference is 3 centimetres away. Everything outside is more, and everything inside is less than 3 centimetres away. What practical purpose could this have? Well, imagine that the point here at the centre is a town. And imagine that what we want to do on a map is mark the area where a new shopping centre could go. And perhaps the new shopping centre has to be less than 3 centimetres on the map away from the town centre. Where could the shopping centre go? Well, it could go anywhere within this circle. Perhaps, alternatively, it's a power station we're going to put near this town. And the power station has to be more than 3 centimetres away. So where would the power station go? Well, anywhere on the outside of that circle. A very practical purpose, finding regions around a certain point. For example, here is a map. The map shows 2 towns, Burford and Hightown. I've got a scale for the map, 1 centimetre represents 10 kilometres. A company is going to build a warehouse. The warehouse will be less than 30 kilometres from Burford and less than 50 kilometres from Hightown. Shade the region on the map where the company can build the warehouse. So we have 2 points marked on a map. And we need to find a region that is less than a certain distance away from one and less than a certain distance away from the other. Well, we can treat those 2 distances one at a time. And it will be exactly what we've just been talking about with the loci, with the regions around a particular point. So we need to work out the scale first of all. Well, if 1 centimetre is 10 kilometres, then 30 kilometres here will be 10, 20, 30, that's 3 centimetres. And 50 kilometres, 10, 20, 30, 40, 50, so that will be 5 centimetres. Which means we're going to have to draw a 3 centimetre circle, or a circle of radius 3 centimetres around Burford, and a circle of 5 centimetre radius around Hightown. Let's do Burford first, so we grab our compass, we set it to 3 centimetres using our ruler, and then we draw the circle in around Burford. So there is a 3 centimetre circle around Burford. And around Hightown, we need to draw a 5 centimetre circle, so we grab our ruler again, we reset our compass to 5 centimetres, and we draw a 5 centimetre circle around Hightown. Now I'm going to allow my circle to stop at the edges of the map. Could draw a whole circle if we wanted, though, it doesn't matter, it's just that the map stops us from going any further, and that's okay, that's fine. So anything on this circle here, the 3 centimetre circle, is exactly 3 centimetres away from Burford. Anything outside the circle is more than 3 centimetres away. Anything inside the circle is less. Similarly with Hightown, anything on the circle or the curve around Hightown is exactly 5 centimetres, i.e. 50 kilometres away. Anything within the circle is less, and anything outside the circle is more. We need the warehouse to be less than 30 kilometres from Burford and less than 50 kilometres from Hightown. It needs to be less than both, so it needs to be inside both. The only part of this map that is inside both circles is this bit here. So when it says shade the region, this is what we would shade. On these kind of questions, if you're having to draw something on a map, it will usually either be a shade the region or label the region with the letter R. It will be something like that. Shade the region is probably slightly more common though. 3 marks for this question, 1 mark for getting the 3 centimetre circle correct, 1 mark for getting the 5 centimetre circle correct, and 1 mark for having the correct region shaded. We've just seen how to mark out a region of a given distance around a point, a single particular place, like a town for example. You might also have to be able to mark out a region around not a point, but a line. We'll talk about practical applications of this shortly, but let's just find out how to do it first. So let's say we wanted to draw a locus or a region around this line to show all of the points that are less than 3 centimetres away. Well, we need 3 centimetres away from this line in any given direction. So let's do the easy directions first of all, above and below. We want to mark out anywhere that is less than 3 centimetres away from this line above. Well, surely then we could just mark what is 3 centimetres above and draw ourselves a nice line. Because anywhere underneath that line, anywhere within this space here, will be less than 3 centimetres away. We could do the same on the bottom, couldn't we? We could mark 3 centimetres underneath, and then we'd be marking out anywhere that's less than 3 centimetres underneath the line as well. And then you might be tempted to say of the ends, well, surely we could just measure 3 centimetres away here, and mark that point, and 3 centimetres away at the other end, and we'd mark that point there, and then we'd just draw like a nice rectangle around it. Problem being that if we did that, if we were to mark on these points here with rectangles, what about this top corner here? This top corner is, oh actually it's a lot more than 3 centimetres away, it's more like 4 to be honest, and that's a problem, because we only want things that are within 3 centimetres of the line. So clearly this cannot be right. Well, we need to mark on all the points that are within 3 centimetres of the end of that line. So surely we could just draw a curve at the end of that line. Treat the end of the line as a point. Set our compass to 3 centimetres and draw a nice curve from the end of that line. 3 centimetre compass, a nice curve to join these two lines up, like so. And same at the other end. A nice curve to join these lines up. This kind of running track sort of shape. Anywhere within that running track kind of shape is less than 3 centimetres away from a given place. From the line this time, rather than a particular point. Anything on the track shape is exactly 3 centimetres away. Anything outside is more. What's happened really is we've taken the circle around the point and we've stretched it out into a line. We've kind of pulled on the two sides of the circle, left and right, and made this running track kind of shape. What practical applications might this have? Well, imagine this is a road or a wall, and we need to put something within a given distance of the road or the wall. This is a given distance. It is exactly 3 centimetres marked above and below, and marked in any particular direction at the ends. 3 centimetres away in any given direction. This were a road perhaps, or a wall, and we want to mark on where we can put something in relation to that road or that wall. The next thing we might have to be able to draw is we might have to be able to draw what's called a perpendicular bisector. Now that sounds like quite a mouthful, but let's unpick these words and see if we can work out what that might be. Well, this word perpendicular, we've seen that before. Two lines that are perpendicular are lines that meet at a right angle, so we've got something to do with right angles here. Bisector. Well, bi as a word means two. Think about bicycle has two wheels, for example. The sect part of the sector, well, sect, think about things like section or secateurs. And this sect means to cut. So bisector, to cut. Something about cutting this in two, and a right angle. What we need to be able to do then is we need to be able to draw a line at a right angle to this one. So this is a horizontal line, we'll be drawing a vertical line. A line at a right angle to this one that cuts this line exactly in half. Problem is, we are not allowed to do this with a ruler and a protractor. Because if we were asked to do this in an exam, if we were asked to construct a perpendicular bisector, we would have to do it using that trusty old favourite, the compass. How on earth are we going to use a compass that's used for drawing circles and triangles, admittedly, to cut this line in half? Well, here's what we're going to do. We're going to open our compass, first of all, to a width that is any width we like, as long as it is more than halfway along the line. How do we know where halfway along the line is? Well, we don't. Not without measuring it, and we're not going to measure it. But just by eye, open the compass to a width that is clearly more than halfway along that line. It does not matter what width you choose, but you must keep your compass at that width all the way through this question. Next thing I'm going to do, I'm going to place the point of the compass at one end of this line. And I'm going to draw a nice arc, a nice curve around that line there. Keeping the compass at the same width, I'm going to move the compass to the other side of the line. And I'm going to do exactly the same thing there. I'm going to join. I'm going to draw a nice smooth curve. There. And you will hopefully notice something about the two curves. You will notice that they intersect, they cross here, and they cross here. And all I'm going to do with a ruler is I'm going to join those 2 points up. Now I'm going to tell you now that that is a perpendicular bisector, that this is a right angle, and that the point where the two lines cross here is exactly halfway along this line. Let's check that, because it's an easy check. Well, on the left hand side we have got 4 centimetres of line. On the right hand side we're running from 4 to 8, that's another 4 centimetres of line, so it's definitely at the halfway point. If we grab a protractor, we should be able to check whether that is indeed a right angle or not. So we grab a protractor, we place the protractor on the line, on the angle, so that the cross sits exactly at the centre there, where the two lines intersect. And do we have a right angle? Yes, we do. We are crossing at the 90 degrees there. That is a 90-degree angle, a perpendicular line, bisecting that line that we started with, cutting that line exactly in two. What might a practical application of this be? Well, imagine that here at one end of the line is town A, and here at the other end of the line is town B, location A and location B. This point here in the middle is what in relation to the two towns A and B? It is exactly halfway between. So imagine we wanted to put something, we wanted to build a certain location exactly halfway between two places. That's where we'd put it. We could join the two towns with a line, bisect that line, find the halfway point. Imagine instead though, if we wanted to put our building that we were going to make closer to town A than town B, where would we put it? We'd put it on the left of that line. If we wanted it closer to town B than town A, we'd put it on the right of the line. So what a perpendicular bisector does is it finds the halfway point between two places, 2 points. It finds halfway between 2 points, and that lets you work out when you are nearer to one or nearer to the other. So a perpendicular bisector finds the halfway between 2 points. The final type of drawing we might have to do is we might have to be able to bisect an angle. So we're talking about bisecting again, talking about cutting in two. Well, that was bisecting a line we've just done. This is bisecting an angle. Again, we'll talk about practical purposes shortly, but bisecting an angle simply means cutting this angle in two. Now, obviously, we could measure the angle and then we could mark on the halfway point of that and draw a line. But again, we're having to show that we're doing it with a compass. We're leaving all those lines intact at the end so that we can show that that's what we're doing. But we need to be able to cut this angle in two using, once again, a compass. So, what I'm going to do is I'm going to set my compass to any width that I like. And it really can be any width for this. There's no restrictions on it at all, as long as we keep the compass at the same width all the way through. I'm going to place my compass at the point of the angle. And I'm going to use my compass set at my width. Just mark somewhere along the baseline and somewhere along the upper line as well. Just mark those at that particular width. I'm then going to move my compass so that the point now sits there, where I've just made that mark on the baseline. And I'm going to use my compass and I'm going to draw another curve. Much bigger this one, just because it'll need to be. Same width all the way through, notice. I'm going to move my compass and I'm going to do the same at the crossing point for the upper line. And I'm going to draw a nice smooth curve there as well. And I'm going to hopefully notice that those two curves, the larger curves that I've drawn, cross at a particular point. I'm going to grab my ruler and I'm going to join that point where they cross to the angle. I should now have bisected that angle. I should have cut that angle into two equal pieces. Let's check. Well, the angle overall, if we measure the whole angle, that would be 73 degrees. And if we look halfway along, well, we are at 36. I'd say that's about halfway along. 72 or 3-ish. 36, that seems reasonable. We have bisected that angle. But what practical purpose could this possibly have? Well, imagine this is a point A, B and C. And A, B and C are towns, for example. A to B is a particular road. A to C is a particular road. Anywhere on this line here in the middle is exactly halfway between the two roads. So if we wanted to put a service station between the two roads, exactly halfway between the two roads, then we could put it anywhere along this line. Because this line is found exactly halfway between two lines. Bisecting an angle finds exactly halfway between two lines. Anywhere in this space up here, above that line we've drawn, is closer to AB than it is to AC, closer to this road than it is to this one. Anything down here is closer to this road than it is to this road. These could also be garden walls, for example. These are 3 points in a garden, 3 corners of a garden. Here is one wall, here is the other wall. We might want to put a tree closer to the wall AC than the wall AB. Where will the tree go? Well, if this line is exactly halfway between the two walls, anywhere here, the tree will be closer to AC than it would be to AB. So bisecting an angle finds exactly halfway between two lines. Here is a scale drawing of a rectangular garden A, B, C, D. We've got a scale given to us. 1 centimetre represents 1 metre. That's quite a nice scale to be using. Jane wants to plant a tree in the garden. At least 5 metres from point C, nearer to AB than AD, and less than 3 metres from DC. On the diagram, shade the region where Jane can plant the tree. So, we really need to be thinking about these contexts here and thinking about which of the constructions, because it is those constructions, we're going to be drawing for each one. I'm going to do the at least 5 metres from point C first of all. Now point C is a particular corner in the garden, which is a single point. And I need at least 5 metres from point C, i.e. more than 5 metres from point C, further away than 5 metres. So I need to know where 5 metres away from C is, but that's in any given direction. And if we're talking about distance from a particular point in any given direction, we must be drawing these loci, these circles, areas around a particular point. 5 metres, so we're going to set our compass to 5 centimetres, as 1 centimetre is 1 metre, and I'm going to draw a curve from C. Now that curve there is 5 meters away from C. I need at least 5 meters, so I need to be further away than that. I need to be outside the circle, but we'll come to that shortly. So that's the first one there, number 1, ticked off. I'm going to do the last one next, number 3, less than 3 meters from DC. Now that is within a certain distance of a line. DC is a particular line, so what I'm going to be drawing is I'm going to be drawing a running track. So I'm going to go 3 centimeters, 1 centimeter is 1 meter, remember, 3 centimeters above that line DC. And I'm going to draw that in. And then actually I'm going to find that, well, surely the running track would just carry on round here and it would be outside the map. So that's it. We're 5 centimeters away for that first one with the curve, and then we've drawn a very similar thing, another locus around the line. It's just that most of it gets cut off by the garden walls this time. Now, I would be less than 3 meters from DC, so I need to be within the 3 centimeters that I've just drawn. I need to be under this line and outside the curve. So we're starting to put together what we've got here. That's number 3, and I've done that third bit. Now this middle one is the hardest thing to do. I need to be nearer to AB than AD. AB is a line, AD is a line. And I'm talking about being nearer to one line than another line. That means we need to find the halfway point between 2 lines. And finding the halfway point between 2 lines means that I need to bisect the angle. Which angle? Well, the angle where those 2 lines meet, i.e. this one here. I need to bisect that angle. Which means I need to set my compass to any width I like. Put a little dash on that top line and a little dash on that bottom line. Move my compass to each of those points. Put a nice curve in from the top one and a nice curve in from the bottom one. Where those 2 curves cross is the point that I need to join up to the angle. So this is me bisecting that line. I'm going to extend it straight down to the garden wall just to make a nice fenced off area there. Anything on that line is exactly halfway between the 2 lines, the 2 walls of the garden, AB and AD. I need to be nearer to AB than to AD. So anything above this line, anything up here, is going to be nearer to this wall than it is to this wall, because that's the whole point of finding the halfway point. Once I've found halfway between, anything above here is going to be closer to this upper wall than it is to the left-hand one. So I need to be above that line number 2, outside line number 1, and underneath line number 3. I need to shade the region where we can plant the tree. Well, the only area that fits all of those is that one there, shaded in the middle. This is a 4-mark question. 1 mark for the curve number 1, 1 mark for the line number 2, 1 mark for the line number 3, and your 4th mark for getting the right region in the middle shaded.